Classify small photos of objects. The Cifar-10 small photo classification problem is a standard dataset used in computer vision and deep learning. Although the dataset is effectively solved, it can be used as the basis for learning and practicing how to develop, evaluate, and use convolutional deep learning neural networks for image classification from scratch. Cifar-10 Photo Classification Dataset. Cifar is an acronym that stands for the Canadian Institute for Advanced Research, and the Cifar-10 dataset was developed along with the Cifar-100 dataset by researchers at the Cifar Institute. The dataset is comprised of 60,000, 32 × 32 pixel color photographs of objects from 10 classes, such as frogs, birds, cats, ships, etc. The class labels and their standard associated integer values are listed below. 0. Airplane. 1. Automobile. 2. Bird. 3. Cat. 4. Deer. 5. Dog. 6. Frog. 7. Horse. 8. Ship. 9. Truck. These are very small images, much smaller than a typical photograph, as the dataset was intended for computer vision research. Cifar-10 is a well-understood dataset and widely used for benchmarking computer vision algorithms in the field of machine learning. Import the required libraries. In 45, from TensorFlow.keras.datasets. Import Cifar-10 from TensorFlow.keras.utils. Import to_categorical from TensorFlow.keras.preprocessing.image. Import image data generator from TensorFlow.keras.models. Import sequential, load_model from TensorFlow.keras.layers. Import conv2d from TensorFlow.keras.layers. Import max pooling 2d from TensorFlow.keras.layers. Import batch normalization from TensorFlow.keras.layers. Import dropout from TensorFlow.keras.layers. Import flatten from TensorFlow.keras.layers. Import dense from TensorFlow.keras.optimizers. Import sgd. Import numpy as np. Import matplotlib.pyplot as plt. Load train and test dataset. In 36, def load_dataset, #load dataset, x_train, y_train, x_test, y_test, equals Cifar-10.load_data. #1hot encode target values y_train equals to _categorical, y_train, y_test equals to _categorical, y_test. Return x_train, y_train, x_test, y_test. Show some training images. In 37, train_images, train_labels, underscore equals load_dataset. Labels equals airplane, automobile, bird, cat, deer, dog, frog, horse. Fig equals plt.figure, fig size. Equals 20, 4, for idx in range, 20 plt.subplot, 210, idx plus 1, sticks equals, itix equals, plt.imshow, train_images idx, plt.title, labels train_labels idx.argmax. Scale pixels. In 38, def prep_pixels, train, test. Hashtag convert from integer to float train underscore norm equals train datatype, float 32. Test underscore norm equals test datatype, float 32. Hashtag normalize the range 1 to 0 train underscore norm equals train underscore norm slash 255.0 test underscore norm equals test underscore norm slash 255.0. Hashtag return normalized images return train underscore norm, test underscore norm. Define CNN model. In 39, def define underscore model, model equals sequential. Hashtag first convolution block model.add, conv2d, 32. 3. Kernel underscore initializer equals he underscore uniform, activation equals rel model.add, batch normalization. Model.add, conv2d, filters. Equals 32, kernel underscore size equals 3. Kernel underscore initializer equals he underscore uni model.add, batch normalization. Model.add, max pooling 2D, pool underscore size. Equals 2. Model.add, dropout 0.2. Hashtag second convolution block model.add, conv2d, filters. Equals 64, kernel underscore size equals 3. Kernel underscore initializer equals he underscore uni model.add, batch normalization. Model.add, conv2d, filters. Equals 64, kernel underscore size equals 3. Kernel underscore initializer equals he underscore uni model.add, batch normalization. Model.add, max pooling 2D, pool underscore size. Equals 2. Model.add, dropout 0.3. Hashtag third convolution block model.add, conv2d, filters. Equals 128, kernel underscore size equals 3. Kernel underscore initializer equals he underscore unmodel.add, batch normalization. Model.add, conv2d, filters. Equals 128, kernel underscore size equals 3. Kernel underscore initializer equals he underscore unmodel.add, batch normalization. Model.add, max pooling 2D, pool underscore size. Equals 2. Model.add, dropout 0.4. Hashtag flatten layer model.add, flatten. Hashtag first dense layer. Model.add, dense, units. Equals 128, kernel underscore initializer equals he underscore uniform, activation equals rel model.add, batch normalization. Model.add, dropout 0.5. Hashtag second dense layer model.add, dense, units. Equals 10, activation equals softmax. Hashtag compile the model opt equals sgd, learning underscore rate equals 0.001, momentum equals 0.9, model.compile, loss. Equals categorical underscore cross entropy, optimizer equals opt, metrics equals acc return model cnn underscore model equals define underscore model, cnn underscore model dot summary. In 42, def summarize underscore diagnostics, history hashtag plot loss plt dot subplot, 211. plt.title, cross. Entropy loss, plt.plot, history loss, color equals blue, label equals train, plt.plot, history val loss, color equals orange, label equals test, plot accuracy plt.subplot, 212. plt.title, classification. Accuracy, plt.plot, history, accuracy, color equals, blue, label equals, train, plt.plot, history, val accuracy, color equals red, label equals test. Run the test harness for evaluating a model. In 44, def run _test harness, load dataset x train, y train, x test, y test equals load dataset, prepare pixel data x train, x test equals prep pixels, x train, x test. Define model equals define model. Create data generator datagen equals image data generator. Width shift range equals 0.1. Height shift range equals 0.1. Prepare iterator train equals datagen.flow. X train, y train. Batch size equals 64. Fit the model steps equals int. X train shape 0/64. History equals model fit. It train. Steps per epoch equals. Steps, epochs equals 25. Validation to save the trained model.save. /content/drive /my drive /deep learning and computer vision /saved models #learning curves summarize diagnostics history evaluate the model ACC equals model.evaluate x test y test print %.3f ACC asterisk 100.0 run the test harness run test 0. Load the trained model. In 46, model equals load model /content/drive /my drive /deep learning and computer vision /saved test model on some images. In 68, target classes equals airplane, automobile, bird, cat, deer, dog, frog, horse. Load test data x train, y train, x test, y test equals load dataset. Normalize pixel data x train, x test equals prep pixels, x train, x test. Predict the target classes of test images y pred equals model.predict, x test. In 74, plot test images with predicted classes by the CNN model fig equals plt.figure, fig size equals 20, 4, for IDX in range, 20 plt.subplot, 210, IDX plus 1, sticks equals, itix equals, plt.imshow, x test IDX, plt.title, classes y pred IDX.argmax.